And finally, we get to start our ration formulation. What we've been waiting and prepping all semester for is to start figuring out how do we make rations for animals. And that's what we're going to be spending the rest of the semester doing. The first few weeks of this process, we're going to learn to do it by hand and with hand calculations, because we need to understand the premise that the computers are going to be giving us. And so for the next couple of weeks, we're going to talk about what information is needed for ration formulation, the methods of ration formulation, as well as practicing it. And it takes a lot of practice. You know the old saying, practice makes perfect. So we will be doing quite a few problems and getting a good feel for how this works. Some of the key information that we're going to be needing for ration formulation includes the nutrients required for animals. And if you notice, we've been working usually with the feed ID or the feed table in the book, but now there's a whole bunch of other tables back in there, and we're going to start learning to use those to look up our nutrient requirements for the animal. We know that these requirements change over their life cycle. We've gone through the nutrient requirements for maintenance and for reproduction, lactation, for growth, and we're going to start exploring how we actually find the actual values for specific requirements like protein, energy, dry matter, etc. We need to know what feeds we have available. Most of the time this is going to be given to you in the problems. It's going to be based upon the scenario and what regional area. Sometimes I have you guys do problems for other states just to get a feel for what feeds are available in Oklahoma, Iowa, Florida, some different places to kind of just broaden your horizons a little bit about feed availability. We'll also need to know feed costs and some things like that. We're going to start incorporating feed costs into some of the cases. So remember how we did that activity that we looked at feed cost per pound of nutrient, whether it's dry matter, protein, energy, whatever the case may be. We're going to need to be doing that, and so we'll continue practicing some of these basic skills that we've done up front clear throughout this process. We need the feed composition. You guys have become champions at that, looking up the feeds in that feed table or perhaps the Noble Feed Library, depending on what we're working with. And so we're going to continue working with feed composition data. When we talk about ration formulation, keep it simple. Don't try to get crazy with the feeds you might be able to choose from or anything like that. Keep it simple. Keep yourself organized. I do recommend showing all of your work because then we can help you find errors. Some of this stuff could be done in the head, but I recommend in the beginning writing everything down, mapping it all out, keeping yourself organized so that we can check the process as we go through this learning process. Definitely have to pay attention to as-fed versus dry matter basis. Make sure you're working all in a dry matter basis or all in an as-fed basis. A lot of times I require that we're working in a dry matter basis. Make sure all your data is coming in on that form. We can formulate rations on either an absolute or a concentration basis. When we talk about an absolute basis, it means amounts. This is like pounds, kilograms per day. So it's a per day amount that an animal is eating. Calories, like mcals per day. And so it's how many pounds of protein is that horse eating? How many megacalories of digestible energy per day is that horse getting? When we talk about a concentration basis, that is going to be percentages, parts per million. So that's like a percent protein, percent TDN. When we talk about like calories per pound or calories per kilogram, those types of things, those are considered a concentration that can apply to any weight. Two different schools of thought. I will say that the absolute basis, if given a choice, absolute is probably the most accurate because you know that's the exact quantity of protein or energy that animal needs. Whereas on a concentration basis, you may solve for these percentages, but that's totally hinged upon how much they eat. And so it's kind of, the preference is to do it on an absolute, but we're going to learn on a concentration, and we'll do a mix of both actually throughout our problems. We do have some rounding rules for the class, and I do want you to pay attention to this. I am a stickler. Your grading will depend upon this. Always round to 2 decimals. So that means x.xx. We round up or keep it the same as needed as per standard rounding rules, and we always want to carry to 2 decimals. In certain problems, if we're working with things like calcium and phosphorus in really tiny amounts, I want you to carry at least 4 decimal places throughout the entire problem, and then at the very end round to 2 decimal places. It's just because those minerals are in such small amounts that we need to be able to be as accurate as we possibly can. And so when you submit your homeworks for these problems, I expect you to submit up to 2 decimal places. So our goals for this process is we're going to take a couple of feeds. And we will start off learning just working with 2 feeds. Then we'll work with 3 feeds and some other ways to handle multiple ingredients. When we get into the computer software, we'll handle quite a few ingredients. But by hand, I just want you comfortable with the process using 2 feeds. So in this case, say we're feeding a cow. We're going to take some forage or roughage as well as an energy feed such as corn, and we're going to try to balance them in some certain ideal ratio that's going to meet the needs for our animal. It's going to, whatever percent protein, TDN that this little cow needs, we want to find that perfect balance between hay and corn to be able to meet its needs. So we are going to be working with that premise of trying to take these feeds, balance them together to meet that ideal nutrient balance for our animal. We're going to, like I mentioned earlier, we're going to start off with some hand calculations. We're going to do 3 methods. One's the Pearson square, which is what we're going to be doing the first week. The second is algebra. Don't freak out on me. This is where actually we learn that algebra has a purpose and makes sense in an applied setting. It's not that bad, totally doable. And then we're also going to work through what we call a substitution method, which is kind of like trial and error. And is the substitution method is really good when you have to supplement grazing cattle. It works really well in that type of a setting, but you can also balance rations using the substitution method. And then that gets us through spring break. After spring break, we go to the computers. We will start using various spreadsheets to balance rations for different species. The industry actually uses specialized software. We can't afford it. So we try to replicate as best we can in a spreadsheet setting. And that's going to be what we're doing, is working on specific case studies the latter half of this semester after spring break. Here are a list of the skills that will be needed as we start moving into the ration formulation part of our semester. And it's stuff we've been doing and building up to. So we've got to be able to convert dry matter formulas or rations to as-fed formulas. We're going to do this in a future problem and make sure you have a good understanding. We're going to do this in one of the Pearson squares. We're going to need to be able to create a mix of ingredients. And so we're going to do a quick example of that in this video. Sometimes we've got to blend several ingredients into one feed just to make it a little easier, especially on the hand calculations. Sometimes you buy it in. We're going to do an example that we want to create a mix on a dry matter basis that's 50% corn, 30% barley, and 20% oats. So these amounts are given to us on an as-fed basis, and we want to make this mix, find out on the mix on a dry matter basis, but what the TDN and that is of this mix. Oop, nope, sorry. I misspoke. All of these numbers here are on a dry matter basis. Our mix is given to us in dry matter. But what we want to solve for is the percentage of dry matter and the percentage of TDN of this mix. So let's take a look at how we would do that. Sorry, forgot to exit my drawing first, then go into the whiteboard. Okay, so let's first just copy down the information that we know we have. Okay, so we know we have corn. And if we look up corn in the composition library that we have in our textbook, we know that it is 88% dry matter, and that the protein, or sorry, TDN, did I say protein on the other one? We're solving for TDN. Sorry if I misspoke on this, I hope it's not too confusing. It's 90% TDN. Then we have barley, which is also 88% dry matter, and it is 84% TDN. And these are both on a dry matter basis here. Then we have oats. Okay? And oats is 89% dry matter and is 77% TDN. So this is our basic compositional information that we got from our feed library. And so we have two tasks that we're going to be charged with. The first task is to solve for the mix dry matter percentage. The second task is to solve for the mix TDN. Okay? And that's supposed to be on a dry matter basis. Okay, so we're going to break this down and do these one at a time. Okay, so let's start with a new whiteboard screen. And let's start with solving for dry matter. Okay, so we know that we have the three ingredients: corn, oats, let's do it this way, same order. Corn, barley, and oats. A lot of times you'll buy cob feed, which is corn, oats, and barley. And so we know that on a dry matter basis we have 50% corn, 30% barley, and 20% oats. This adds up to 100. One way that we can think about this that sometimes helps us out is if we were to say, instead of percentages, we're dealing with pounds of dry matter. So does it make sense to you that 50% could be the same as 50 pounds of dry matter? And 30% could be 30 pounds out of 100, and 20 pounds out of 100 pounds of dry matter. Does that make sense? And because if we can do that, it'll make sometimes converting these formulas and solving for mixes a little bit easier. So in this situation, we want to solve for pounds as fed, because we're going to convert our pounds of dry matter to pounds as fed, because that's going to help us get, we're trying to figure out a percentage of dry matter, and a percentage is simply the part divided by the whole times 100. We know that our part is actually 100 pounds of dry matter. What we need to know is what our total pounds as fed is in this mix. So if we're converting it like 50 pounds from as fed, or from dry matter to as fed, it needs to be heavier because we're adding the water back in. So we are actually going to be dividing by the dry matter percentages. And these came out of our compositional table. They're on the previous screen that we were working with. And when we do this, we find out that we have 56.82, and check my math. You guys have seen that I can screw up math just as easy as anybody can. 34.09 pounds of barley and 22 0.47 pounds of as-fed from the oats. If we add this up, we wind up with a total of 113.38 pounds as-fed. Does it make sense that this number is greater than this number? It makes sense. We added the water back in. Our as-fed weight should be heavier. So now to figure out the percent of the percent dry matter, we're going to use this formula that we looked at over here. We're going to take the part, which is 100, okay, so come in from right there, divided by the whole, which is 113.38, all of this times 100. And when we do that, we come up with 88.20% dry matter, which makes sense considering all three feed ingredients were either 88 or 89% dry matter. So that makes sense. So we know now that our mix of corn, barley, and oats is 88.20% dry matter. The second task that we had to do was to actually solve for the percent TDN. Of these three feeds. So, and we wanted the TDN on a dry matter basis. So we have corn, barley, and oats. We have 50, 30, and 20. If we could think about this as pounds of dry matter. So we want to know how many pounds of TDN is in this. So when we have 50 pounds of dry matter, to figure out how many pounds of TDN, it should be a smaller number because it's a percentage of this 50%. We're going to multiply times the TDN value. In this case, corn was 90, barley was 84%, and oats was 77%. When we do that, we find out that we have 45.0 pounds of TDN. And note, this is all on a dry basis because our units are both in dry matter and dry matter. For the barley, we have 25.20, and then the oats, 15.40. They're all slightly less than the original numbers, meaning that it's a percentage of that. So if we add this up, we find out that we have 85.60 pounds of TDN in our 100 pounds of dry matter. So now we can do our percentage just like we did on the previous slide. We can figure out that we have 85.60 out of 100. If we multiply that times 100, I'm running out of edge there, even though you notice it's actually out of 100, we wind up discovering that we have 85.60% TDN on a dry matter basis. And so this is something you will be doing several times. You'll get lots of practice at this, and it will get a little bit easier. But that's some of the stuff that we're going to be doing on creating mixes and working with mixes. We will be doing one this week in the Pearson Square homework as well to kind of make sure we practice. So this is something that we will revisit and go over in class as well. That wraps up this first introduction to ration formulation video. A little bit longer. I may try to get it broken up into 2 sections to kind of help that out.